Hi children, nice to meet you again this week. Now we will be going on to the next. Today we want to do finite decimals and recurring decimals. Now last lesson we did decimals with the denominator 10, 100 and 1000. We did how to convert with the denominator 10, 100. For example, 3 upon 10. We wrote as 0.3. Now supposing the denominator is not 10, we have denominator like this, we say 1 upon 2. How to bring this to decimal? So what we should do is, we have to make the denominator 10 here. So one method is by equal fraction method, you can multiply by 5, 5 on the 5 which is a 10. So that is equal to 0.5. Same way, we say 1 upon 4. 1 upon 4, we can't write a 0.1, we have to make this 10 or 100. So what you can do is multiply this by 25. So the answer is 25 upon 10, 25 upon 100. That is equal to 0.25. Look at 3/4. Multiply this by 75, 25 again. 25 into 3 is 75 upon 100, that is equal to 0.75. Now these three fractions are very important because very often we come across this while working. So immediately you must know that half means 0.5, 1/4 means 0.25, 3/4 means 0.75. Now it is better for you to enter this onto your formula books and memorize them, because when we are doing something immediately without dividing and multiplying all that, you can immediately write down the answer. Okay. Now we will take another sum. We say 2 upon 5. If you have 2 upon 5, here also we can't immediately write this in decimals. We have to make the denominator 10. So we can multiply by 2, 4 upon 10. Or another universal method there is. That is, what we do is, we divide 2 by 5. This is the universal method for any fraction we want to convert to decimal. What you do is, we divide the numerator by the denominator. Numerator is 2 divided by 5. So we know that the 2 has a decimal here. Same decimal we write there. How many 5 is in 2? 0. Then 20. How many 5 is in 24? So you get the same answer there. Look at this one. 11 upon 25. 25. So here decimal 0. 0. Then here how many 25? Then 11, 0. Then 110. So it will be 4, 100. 1. Then put a 0, another 0, another 4. So 100 coming. So that is equal to 0.44. Now these are called finite decimals. Finite decimal. Why do we call the finite decimals? Because they are stopping at, they are not continuing. They are not continuing. Because here when you divide 2 by 5, it is stopping at 4. No more. With that the answer is over. Then 11 upon 25 with stopping at 0.44. 100. So wherever you get decimals where it is stopping at certain decimals, where it is stopping at a number, then we call it finite decimals. We will take another example. We will say 3 upon 8. 3 upon 8. We will divide 3 by 8. Then decimal. Then 0. Then put a 0 here, 30. Then 8 3s are 24. Then when you subtract 6, then put a 0 here, put a 0, 60. 8 7, 56. Then subtract 4, 40. So 8 5 are 40. So this is equal to 0.375. So these are finite decimals. So finite decimals are decimals that are stopping when you divide with a certain number. So this definition for finite decimals. We will take another example. Supposing we have a fraction 1 upon 3. We have to convert to decimals. What do we do? The universal method, the normal method, we divide 1 by 3. So decimal, 0. So here 10. How many 3 is in 10? 3. 3 is 9. Then subtract 1. Put a 0 here. 10. Then again 3. 9. 1. 0 here. So can you see this is repeating. That is, the 3 is going on and on forever. So this is called recurring decimal. Recurring decimal. Because the same number is being repeated. So and we put a 3 is recurring, so we put a dot there. 0.3. Look at this one. We'll have 5 upon 6. We have to divide 5 by 6. 5 we divide by 6. So decimal there. 50. So 6 8 48. 6 8 is 48. Then 20. 6 3 is 18. Then again 20. And then again 3, 20, 80. So it is continuing how? 0.8, 3 and 3 is continuing. So we put the dot, recurring 3 we put above 3. We don't put above 8, we put above 3. So here it is 3 is recurring, so the recurring number is 3. So 5 upon 6 is equal to 0.83 recurring. So it is another number. So we take another number, we'll say 7 upon 9. We have to divide 7 by 9. 7 by 9. So decimal, 0, 70. So it's coming to 8864. 60, 8756, 40. That's right. 9763, 70. Then again 9763, 70. So it's going on. So here it's coming to as 0.77 repeating. But nice thing about 9 is, so if we have a number 1 upon 9, the answer is 0.1 repeating. If it is 2 upon 9, 0.2 repeating. If it is 5 upon 9, 0.5 repeating. So when you are dividing by 9, you can always tell what the answer is. Repeating number. So if we have number like this, 2 upon 9, immediately we can write the answer 2.2 recurring. So these are about the recurring number fractions, and we studied two things about decimals, but finite decimals where the numbers stop and no more, continue no more, and recurring decimals where the same number is recurring over and over again. So these are for today, children. I hope you understood, and if you like the lesson, please subscribe.